Okay, so we'll begin today's class. Let's start with the first problem. This is, I think, problem 21. So this question says, solve in positive integers the equation x square y square z square minus minimum of x square comma y square comma z square is equal to 2016. This is the question. You have to find the integer solutions for x, y, and z, where this minimum, I hope everyone understands. Minimum of x square, y square, z square is whichever one of them is the smallest one. Is anybody getting anything? First of all, you can say here without loss of generality, you can assume that the order of x, y, and z is like this. So we are saying that x is the minimum. So the equation in that case becomes x square y square z square minus x square is equal to 2016. So basically you can take x square common and you have y square z square minus 1 is equal to 2016. This is the equation. After this is what you have to think about, what you can do here. Can somebody tell me like what is
335.
what?
335.
How did you get 335?
Sir, I basically factorized 2016 and I got 2 to the power into 3 square into 7.
This is what the prime factorization is.
Then after some hit and trial, I got 3 square as x square. I assumed x to be the minimum, and I checked all the cases for the 2 and I didn't find any solution. Then I put x square is equals to 3 square, and from there I got y square z square minus 1 is equals to 224. So from there we got y square z square is equals to 225.
But why are you not checking other higher values also? 4 and 5. Like why not check x as 4 or something also?
Sir, x as 4 I've already checked, but I didn't get any solution from it.
See, the answer is right, but the method has some gaps.
Oh.
You are able to do it only because this number is small, right? Do you understand that you are able to check cases and do it only because this number is small?
Yes, sir.
अगर ये number बहुत थोड़ा सा बड़ा होता 10 times bigger, then you would have to check far more cases, right? समझ में आ रहा है मैं क्या बोल रहा हूँ?
Yes, sir.
क्योंकि अभी तो ये 2 स्क्वायर करके डिवाइड करके चेक हो जा रहा है 3 में, और उसके आगे it is not becoming very large, so you are able to say that it's not fitting. But if somebody just changes the number a little more, then you don't know how much you have to check, right?
Yes, sir.
So the point is you have to think a little more here. The answer is correct, but you have to think a little more. You have to try to find an upper bound for x. Like till where will you check? Or will you keep checking? It is easy to find an upper bound for x. The way you can do that is you should realize that you have assumed what? X is less than equal to y is less than equal to z, right? Correct?
Sir.
So what you can say is for sure, x square times x square is less than y square into z square, right?
Yes, sir.
So basically we can say that x square into, instead of this, if I write x power 4 minus 1, that will be lesser than x square, y square, z square minus 1, right?
It's 200.
Do you understand?
Yes, sir.
So now you are getting x power 6 minus x square is less than 2016, right?
Sir.
From here, what you can now see is x power 6 till where? If you have a 4 power 6, right? Minus 4 square, that is already bigger than 2060. You can
Sir.
see this. If x was 4, this inequality is not true.
Hmm.
So that means x cannot be 4. Obviously, if you put x as 5, it will become even more untrue, right?
Yes.
So basically from here, we get that x is less than 4. So x can be, since it was positive integers, then x can be only 1, 2, or 3, right?
Yes, sir.
Now, since you have eliminated only 3 choices are there, now you can put the values and be sure, right?
Yes, sir.
So hit and trial guess करना है, लेकिन after some analysis, after understanding how much I will guess, right?
Oh,
So answer is correct, 335. And obviously we had assumed that x is less than y is less than z. So all the possible arrangements of this are fine, right? It's not necessary that always it will be like that, right? All of these are solutions. Is everyone understanding what I'm saying so far?
sir.
Okay, let's move on to the next one. Problem 22. If A, B, C are positive integers such that AB minus A plus B is equal to 2016 and BC minus B plus C is equal to 2026. Evaluate CA minus C plus A. If you get the values of A, B, C, after that, this is very easy to find. So even if you can find the values of A, B, C, that is also enough.
So 2017 into 2028 minus 1.
What is A, B, C?
So B is equals to 2, A is equals to 2018, and C is equals to 2028.
Hmm. A is equal to 2018. How are you getting this?
So I factorized AB minus A minus B by adding a 1 on both the sides. And
Mhm.
similarly for the BC minus B minus C.
So you're getting this.
Yes sir. And from here we get कि 2017 और जो 2027 है वो दोनों को प्राइम है. सो जो उनका जो कॉमन फैक्टर है b माइनस वन वो डेफिनेटली 1 होगा, यानी b इज इक्वल्स टू 2 होगा.
You don't have to look at them together also. You can directly say that this is a prime number.
Yes, yes, sir, getting the same answer.
This and this, both of them are actually prime numbers. They don't have to be just co-prime. They are actually prime.
सर वो पता नहीं था 2017 प्राइम है.
हाँ, ठीक है. Finally, from there, we can say that if it's a prime number, the product of them must be one and itself, right?
यस सर.
So उसी से you will get B is equal to 2. After you get B is equal to 2, it is easy to find A and C. And after that, you have to just calculate this, right?
यस सर.
Okay. Question 23. Let A, B, C be real numbers such that A by 2 plus B by 3 plus C by 6 is equal to square root of 2016. Find the minimum possible value of A square plus B square plus C square. This question has to be solved by knowledge of a standard and very important inequality. It's known as Cauchy-Schwarz. Does everyone know this inequality?
Yes, sir. I know.
Does anyone not know? Is there anyone who does not know the inequality? Basically, the inequality says that if you have A1, B1 plus A2, B2 plus A3, B3, the square of this will be less than equal to A1 square plus A2 square plus A3 square multiplied by B1 square plus B2 square plus B3 square. This is the inequality.
So I am getting an answer. I'm 24,192. Like I did the calculation. It's 12 into 2016.
You have made some slight mistake. It's not 12 into 2016. It's something else into 2016.
Okay, sir.
Check your calculations. The way to do it is applying Cauchy's inequality here. So you can think of A by 2 plus B by 3 plus C by 6 as A into half plus B into 1 by 3.
Sir, is it can I say?
Hmm?
Sir, is it 1354752?
No, again, it's too big. Your numbers are coming too big. We have to find minimum possible value of this. Check your calculations. We are going to say A by 2 plus B by 3 plus C by 6 is the written as A into half plus B into 1 by 3, 3 into 1 by 6. Here you can think of A1, A2, A3 as ABC.
2016. The answer.
No. B1, B2, B3 can be thought of as half, 1 by 3, 1 by 6. And now I'll apply Cauchy's inequality to this expression. So I will get from here, I will get A by 2 plus B by 3 plus C by 6.
Sir, is it 5184?
Hmm. The answer is 5184. See how it is coming. This square will be less than equal to A square plus B square plus C square times 1 by 2 square plus 1 by 3 square plus 1 by C square, 6 square. So basically, we already know the value of A by 2 plus B by 3 plus C by 6, which is root 216, 2016. So square is going to become 2016. So getting 2016 is less than equal to A square plus B square plus C square. And this calculation you have to do, it is 1 by 4 plus 1 by 9 plus 1 by 36. So that will be 9 plus 4, 13 plus 1, 14 by 36. So that is actually equal to 7 by 18. Right? So you are clearly getting A square plus B square plus C square is greater than equal to 2016 into 18 by 7. And if you do this calculation, this number is divisible by 7. So you can simply cancel it and you'll get this answer. A square plus B square plus C square is greater than equal to 5184. I hope it is clear to everyone what we are doing. It's a direct application of Cauchy's inequality. You need to understand how this inequality comes, by the way. Does everyone understand why the inequality is true?
Yes, sir.
Okay, if nobody has an issue, then I don't have to discuss it. But if anybody doesn't understand, I can tell you. Otherwise, we'll move on. The next question is solve in positive integers. The equation 2 times x cube plus y cube minus xy by 2 is equal to 2060. Is anybody getting any ideas here?
Sir, I'm thinking to like x cube plus y cube, we can write it as x plus y, x square plus y square minus xy. So we can term it in terms of x square, x plus y whole square minus 3xy. So we can take x plus y as a single term like a and xy as b and solve the equation. So I guess it might get easy.
That is the correct approach. You can simplify this as, I mean, you didn't have to do all this. You can directly write this as x plus y whole cube minus 3xy x plus y.
Yes, we can do this.
And twice of this minus xy by 2 is equal to 2016. Now, it will be easier to solve the question if you just assume x plus y to be one variable and xy to be another variable.
Yes, sir, I'm doing this.
So we will take x plus y is a and xy is b. And this equation starts looking like 4 times
A,
a
cube
cube minus 3ab, right,
minus b
is
is
equal to
430, 2000. Yes,
this is the equation that we are getting, and simplifying it a little bit, 4a cube minus 12ab and minus b is equal to 4032, right?
yes, sir.
So 4a cube minus b common, you can write 12a plus 1 is equal to 4032, right?
Yes, sir.
Okay, this is our equation. Now, what can we think? Looking at this equation, what can you think about it? What do you get from here?
But I'm thinking that D should be a multiple of 4.
Right, you are getting this term is divisible by 4, this term is divisible by 4. So this term must also be divisible by 4, but
Yes,
the 12a plus 1 can never be divisible by 4, right?
yes.
Because
It's
it is
so
odd.
Odd.
So that means b is a multiple of 4.
Yes, sir.
So we are getting one nice thing that B is equal to 4K, right?
So X and Y are even, both.
Hmm.
Uh,
And B is equal to 4K. If I put here, then you will get something if you put 4K for B, right? So for example, 4A cube minus 4K, 12A plus 1 is equal to 4032, right?
yes, sir.
So 4 can get cancelled and you get 12A plus 1 is equal to 1008. And we can actually solve for K here, right?
Yes, sir.
We will get A cube minus 1008 divided by 12A plus 1 is equal to K, right?
Yes, sir.
But from here we know K is an integer.
So AQ minus 1008 12A plus 1 should be divisible by the upper term.
So K, since the question was about positive integers, obviously we also know is a positive integer, right?
Okay, sir. Yes, sir.
Because the
So
question
A
X
must
and
be greater than 10.
basically you had A was positive, no? And B was also positive, right?
Yes,
So
sir.
K is also positive, and if K has to be positive, then the numerator has to be positive here, right?
Yes, sir.
So from here we get A is greater than equal to 11.
I guess 10, sir, not 11.
No, 10 will make it negative.
Oh, yes, sir.
10 cube minus 1008 is negative.
Yes, sir.
Yes.
So A is greater than equal to 11 we are getting. And we also know one nice thing about A and B. One good thing about A and B is there is a connection between them, A and B, because always you know x plus y whole square is greater than equal to 4xy, right?
Yes, sir.
Because when you take it to the other side, it becomes x minus y whole square is greater than equal to 0, which is always true, right?
Yes, sir.
So we know that a square is always greater than equal to 4b by the way, right?
Yes, sir.
Okay. So if you now think about it, 4b. So using this, we
A should
can
be given
uh,
16K.
16k, right?
Yes.
So we're getting a square is greater than equal to 16a cube minus 16,128 it will become, right?
Yes, sir.
Divided by 12a plus 1,
Yeah.
right?
Yes, sir. We can
So
simplify it now.
we can simplify it. So let's do that on the next screen. Or we can do it here only. 1 second. Maybe I should not have taken a 16 common. Yeah. It was not necessary to multiply it actually. Just keep the 16 outside, right?
Yeah.
So you will get a square into 12a plus 1 is greater than equal to 16 a cube minus 1008, right? So
Yes.
12a cube plus a square is greater than equal to 16a cube minus 16 into 1008, right?
Yes, sir.
Okay, so bringing everything to one side, you get 4a cube
I
minus a square minus 16 into 1008 is less than equal to 0.
yes.
Right. Now, here, let's think about it. This part is what? This is 4 into 252, right?
Yes, sir.
4
It's
into 252. And 252 is also divisible by 16 as far as I can see.
yes, sir.
No, it is not it. Is it?
It will be 16 into 9 into 7, I guess.
It is divisible by 4, you will get 63, right?
Yes,
And
sir.
then it is 9 into 7.
Yes.
So you have 16 into this thing, right?
Yes, sir.
So notice that this is a 16 square into 9 into 7, right?
Hmm.
So it's a 16 square into 63, right?
Yes, sir.
And here if you put 16, you will get 4 into 16 cube. So that is 64 into 16 square, right?
Yes, sir.
And can you see that 16 fits?
Yeah.
See what is happening. This
It's
is cancelling, no?
yeah.
16 is a root of this, right?
Yes, sir.
So basically, you can take a minus 16 as a factor outside of this, right?
Yes, sir.
That is important because that helps us simplify it and make it a quadratic, right?
Yes, sir.
If you can guess a root, it is very useful. So what we will do now is we'll just factorize it. And basically, factorizing is just dividing a minus 16, the expression by a minus 16.
Yes, sir.
So if I take a minus 16 out, you can check it yourself. You will get inside 4a square plus 63a plus 1008. You can check the division. This is what will come. Okay.
Yes, sir. It's coming.
So once you get this, notice that this term, the discriminant of this term is less than 0.
Huh.
63 square minus 16 into 1008, right?
Huh.
You can check this. 63 square, and this is 16,128, right?
Yeah.
So
So,
this is always going to be positive, right?
huh.
So that means this has to be negative, right?
Huh.
So
So A
that
should
means, so now we are getting a good bound on A, 11 to 16, right?
12 or 16. It's possible.
Hmm.
Can be 12 or 16.
So also what we can do is basically now you can just check also. Okay.
Yes.
Since we know so many things now about A and B and all, and we know A is between 11 to 16, you can just check all the even numbers, right?
Huh.
So what you will get is A should be 16. That is what fits.
Yes.
Everything that we have seen so far, A is 16, and once you get A is 16, B also comes as 16, 64.
Huh.
From the initial equation only, you can say if A is 16, B will be 64. Okay.
Yes.
And once you decide this, you will get X and Y both have to be 8.
Huh.
So the question is like a little bit of number theory. You have to notice the divisibility part, right? B is equal to 4k, and then use that back in the same equation to get this condition. And because k is an integer, we got one inequality. A is greater than or equal to 11. And the other inequality comes by actually multiplying this, getting this equation, right?
Yes.
We had a square into 12a plus 1 is greater than this, is what we got, right? How did we get this in? Oh, we got it by a square greater than or equal to 4b, which was an important idea, right?
Yes, sir.
A square greater than or equal to 4b, that's how we got started with this, right? And from there, we eventually got a is less than 16. Once you limit it to 11 to 16, you can just check all the even numbers and see which one works, right? I hope everybody is understanding what we did. Okay.
Yes,
Next one is this question. Problem 25. Let AK be real numbers such that AK is greater than or equal to K for K goes from 0, 1 till 62. And you also have A0 plus A1 plus till A62 adds up to 2016. and square root of a naught plus square root of a1 minus 1 multiplied by a2 minus 2 plus square root of a3 minus 3 multiplied by a4 minus 4 and so on till the last term, which is square root of a61 minus 61 multiplied by a62 minus 62. This thing is equal to 32. So a lot of data has been given, lot of information has been given. Now we have to evaluate a0 minus a1 plus a2 minus a3 so on till minus a61 plus a62. You have to find the value of this expression. Notice that ak is not an integer, it's a real number. And all the ak's are bigger than the k. So basically you have a0 is greater than 0, a1 is greater than equal to 1, a62 is greater than equal to 62. It's a nice question. Once you get the solution, you will find it interesting. Is anybody getting anything?
Sir, please, 2 minutes.
Hmm. The hint is you have to use ANGM inequality. I hope everybody is aware of the inequality. This is true as long as A and B are positive reals, according to the
Sir,
inequality. What do you mean? What is your answer? 1 is not correct. How are you getting 1?
Sir, I observed the symmetry there. Ki, if if we substitute a naught by some x plus 0, similarly ax to be x plus some x plus the coefficient, then we can substitute, we get a sum plus 19, we get the sum of initial 62 natural numbers, which is 1953, and by the symmetry I got that.
Nothing is gotten yet. What are you saying? I got what? ऐसे ही जंप नहीं करना है ना कंक्लूजन पे कुछ भी.
But I'm thinking to apply same given equality in A1 minus 1 and A2 minus 2.
नहीं ठीक है. अमन बताओ तुम by symmetry how did you get 1? I don't understand. Please explain.
सर मैंने हर एक को ना सब्स्टिट्यूट कर दिया कि ए नॉट को मैंने समथिंग एक्स प्लस 0, ए वन को समथिंग एक्स वन प्लस 1, ऐसे करते
Great.
सो ऑन अप टू ए 62 को एक्स
What is 1 plus 2 till 62?
1953.
तो बचा क्या?
सर फिर रिमेनिंग जब सब्ट्रैक्ट करने के बाद आया 2016 माइनस 1953, तो वो 63 आया.
ओके तो वो 63 है.
तो
तो तुम्हारा
उसके बाद
न्यू
अगर हम
वेरिएबल्स बन गए x0 x1 ऐसे करके x62 इज इक्वल टू 63.
6, हाँ, और जब हम ये अंडर रूट वाली इक्वेशन को देखें तो इसमें हर एक टर्म जो है वो ग्रेटर देन इक्वल्स टू 0 है. मतलब a1 माइनस 1 जैसे है वो ग्रेटर देन इक्वल्स टू 0 है.
फाइन.
और ये टोटल 32 टर्म्स हैं.
ये टोटल कितने टर्म्स है?
32.
32 टर्म्स कहाँ से आ रहे हैं यहाँ पे?
सर हर एक
32.
की दो की पहली. सर ये हर एक की पेयरिंग हो रखी है ना.
तो 61 62 है यहाँ पे और 31 और 1 32. हाँ 32 टर्म्स है. सो
A1 से अगर ये 61 तक काउंट करें तो ये टोटल 62 टर्म्स हैं. तो फिर डिवाइडेड बाय तो 31 और A नॉट 32.
हाँ 32 टर्म्स है. फिर आगे क्या है?
तो मैं अगर सबको 1 1 असाइन करूं तो इससे मुझे एक सिमेट्री से एक पैटर्न ये मिलेगा कि अगर हर एक टर्म a के जो है वो अगर k प्लस 1 है तो ये फंक्शन ये दोनों इक्वेशन सेटिस्फाई कर रही है.
बेसिकली इस स्टेप में तुमने सब अज्यूम कर लिया कि इट्स ऑल वन.
बट सर ये सेटिस्फाई भी तो हो रहा है.
सेटिस्फाई ये इक्वेशन मतलब रूट ऑफ एक्स नॉट प्लस रूट ऑफ x1 x2 प्लस रूट ऑफ x3 x4 जो तुम्हारा वेरिएबल्स है, इट एड्स अप टू 32. Just because the 32 variables are there, all variables have to be 1.
सर मैं इसको 32 को 1 1 डिस्ट्रीब्यूट कर सकता हूँ ना इन.
तुमको किसने बोला कि 1 इंटीजर वैल्यूज ही होंगे सबके?
हाँ इंटीजर नहीं हो सकती बट वो एक सेटिस्फाई कर रहे थे तो मैं मुझे लगा वो एक चांस है.
ये जेई या मल्टीपल चॉइस एग्जाम नहीं है. तुमको समझ में आ रहा है कि एग्जाम किस टाइप का है?
यस.
उसमें प्रूफ दिया जाता है.
यस सर.
ये प्रूफ है तुम्हारा. ऐसे करके क्वेश्चन सॉल्व नहीं करना है. These are bad habits from preparing for multiple choice questions वाले एग्जाम. This is not even close to a logical proof. This is just hope. मैं होप कर रहा हूं कि हो जाए, सब 1 हो जाए तो कितना अच्छा होता. समझ रहे हो?
Yes, sir.
Hoping is good, but then you have to prove it also. ऐसे हैबिट्स मत
Sir,
रखो, नहीं तो फिर दिक्कत होगी तुमको बाद में. तुमने आइडिया सही ही किया है शुरू का पार्ट, लेकिन उसके बाद फिर तुम बस गेस कर रहे हो.
sir, I'm getting that A1 is equal to A2 is equal to A3.
क्या बेसिस है? व्हाई? हाउ?
Sir, I I applied like A1 plus A2 minus 3 divided by 2 is greater than equal to under root A1 minus 1 into A2 minus 2.
1 second. A1 plus
A2
uh,
minus 3,
mm-hmm,
like I add minus 1 and minus 2,
mm-hmm.
and then divide by 2 is greater than equal to under root A1
Basically
minus.
AMGM inequality on this term.
Yes, sir, this term. And similarly on all the terms that has been written.
Mm-hmm.
And
तो
then
उससे
sir,
क्या
we
आ रहा है?
add all the terms for
हम्म,
both sides. And then sir, in the LHS side, we get A1 plus A2 dot dot A62
हम्म,
and minus a term of AP, which this is equal to 31 into 63.
हम्म,
And then divide by 2 is already here, which is greater than equal to this term, that is equal to 32 minus root of A naught.
हम्म.
And then sir, from here, we get A naught is equal to 1.
A naught is equal to 1.
Because sir, this inequality ends at under
हम्म.
root A naught minus 1 ka whole square is less than 0. But a square is can't be less than 0, hence it should
फिर
hold the inequality.
फिर और क्या आ रहा है?
Yes, sir.
हाँ, और क्या आ रहा है आगे?
फिर सर यहाँ पर लेस देन 0 आ जा रहा है ना इनइक्वालिटी पे, तो सर रूट ए नॉट को 1 होना पड़ेगा.
ऐसा होना चाहिए कि एवरी स्टेप पे एएमजीएम का इक्वालिटी केस आना चाहिए. बस शुरू वाले टर्म पे ही नहीं, सारे टर्म्स पे तुम्हारा इक्वालिटी केस आना चाहिए एएमजीएम वाला. समझ में आ रहा है मैं क्या बोल रहा हूं? तुमने यू हैव डन एएमजीएम सो मेनी टाइम्स, राइट? You have to show somehow that every part where you have applied AMGM, every step of the way, it has to be the equality case of AMGM.
But by adding all the term, is it not work if equality holds?
Equality has to hold. That's what I am saying. That is what will come for you. You are saying correct only, but you are only saying till A naught is equal to 1, right? What about others?
But sir, that condition for a naught comes when we do this process, like adding all the.
So do that process and then calculate this. What is coming for you for this?
For 1.
नहीं, वो गलत कर गया. थोड़ा सा कुछ लास्ट स्टेप तुम मिस कर रहे हो. ठीक है. So basically I will show you what is happening. The first relation is A naught plus A1 plus A2 till A62 is equal to 2016, and it has been given AK is greater than equal to K. So we will do, and because the other expression has roots and all, what we will do is A naught minus 0 plus A1 minus 1 plus A2 minus 2. We will write all of these terms like this. So obviously on the other side, we have to do 2016 minus 1 plus 2 plus 3 till 62, right? So this side, what you will get is 63 finally. Everybody has done this by now, right?
Yes, sir.
This
Yes,
till
sir.
here, everybody has done. A62 minus 62. This is what everyone is getting. Okay. Now, what we need to do is apply AMGM somehow, because then only we will get roots and all. So यहाँ पे देखोगे कि these are 62 terms, right? And this is a term that is alone on its own, right? So what we will do is AMGM on 2 at a time, right? वैसे ही दूसरा वाला रिजल्ट उसी टाइप से है ना, A1 - 1 and A2 - 2, right? Correct?
Yes, sir.
So what we will say is the expression A0 plus A1 - 1 plus A2 - 2, let's write it like this, plus A3 - 3 plus A4 - 4 will be, ऐसे करके, this whole thing will be greater than equal to A0 plus 2 times root over A1 - 1 and A2 - 2, right? Plus 2
Yes.
times root over A3 - 3 and A4 - 4, right? ऐसे करके आएगा, right? Finally, last, I'm grouping two terms at a time, right? Greater than, finally, it will be A61 - 61 multiplied by A62 - 62. Correct? Is everyone
sir.
understanding what I have done so far? Right?
Yes, sir.
Also, this first term also, it would be nice if we can write something similar to this for the first term, because this first term is ruining everything for us right now. Right? I cannot take anything common because of this A0 term, right?
Yes.
So what we will say, let's check if we can say an inequality for A0. Can we say A0 is greater than 2 times root A0 minus 1? Let's check this, whether this is true or not. Okay. So this is clearly true because A0 plus 1 minus 2 root A0 is greater than equal to 0, right? Because this is root A0 minus 1 whole square. Can you see this?
But sir, it is a +2 आएगा अगर LHS में लाइन इसमें 2 पूरे मल्टीप्लाई है.
वो हाँ, मैंने गलत लिखा है उसको, ऐसा है, ब्रैकेट नहीं है. ओके.
Yes, sir.
Is this correct? This is correct because of this, right? Is everyone
Yeah, sir.
understanding what I'm saying?
It is AMGM also.
So now what I will say is, I will write here, instead of that I will write 2 root A0 minus 1 here, right? So this term also becomes 2 root A0 minus 1 and plus all of these terms, right? Correct?
Yes, sir.
And now notice that this minus 1 I can bring outside here. And now what is this whole expression? Twice of root A0 plus root of this plus root of this plus root of this, right? Correct?
Yes, sir.
What I'm asking you to notice is the right hand side right now. The right hand side is looking like this. Twice of root A0 plus root of A1 minus 1 times A2 minus 2 and so on till the last term, and there is a minus 1 here, right, at the end. Correct? And question में ही दिया हुआ था कि ये, this has a value of how much according to the question? 32. Can you see the second result that I wrote down in the question earlier? I hope everybody is seeing what I'm saying.
Yes, sir.
So this is becoming what? This right hand side stuff is actually equal to 63, right? ये part 63 हो रहा है ना?
Yes, sir.
And left hand side was actually supposed to be greater than equal to this, right? Correct?
Yes, sir.
And earlier we have seen left hand side was 63, right? That was our first step.
Yes.
So we are getting 63, left hand side is greater than equal to 63. So this is the equality case, right? What I mean by equality case is that there have been AMGM has been applied 32 times, right?
Yes, sir.
Every time here I have applied, here I have applied, and so on. But somehow the answer is such that both sides are still equal. Although I would expect the left hand side should have been bigger than right hand side, right?
Yes, sir.
दोनों साइड
Yes.
अभी भी बराबर हैं, लेकिन होना चाहिए था क्या? लेफ्ट हैंड साइड शुड हैव बीन बिगर, नो?
Yes, sir.
So that means every place the AMGM is not an inequality, it is the equality case, right?
So all the terms are equal.
Equality case AMGM में तभी होता है जब A is equal to B, right? Do you understand what I'm saying?
Yes, sir.
So all the terms on which I have applied AMGM must be equal, right? So what you get is A1 minus 1 is equal to A2 minus 2. So basically this means A1 is equal to A2 minus 1, right? Correct?
Yes,
This
sir.
also gives us A0 is
Yes.
equal to 1. Equality happens only if A0 is 1 here, right? This gives us A0 is 1. This gives us the difference between any two terms is 1. Like you can say that A2 minus A1 is 1, right? Correct? And similar results will be true. A4 minus A3 is also 1, right? Is everyone understanding?
Yes, sir.
Yes, sir.
So you are getting a lot of results. No, A2 minus A1 is 1, A4 minus A3 is 1, right? Because A3 minus 3 is equal to A4 minus 4, right?
Yes, sir.
तो बहुत सारे ऐसे रिजल्ट आ रहे हैं A2 minus A1 1, A4 minus A3 1, and so on. And finally, the question is asking us to evaluate what expression? A0 minus A1 plus A2 minus A3 plus A4 till minus A61 plus A62. And now it is just a matter of grouping it correctly. It is A0 plus A2 minus A1 plus A4 minus A3 till final one is A62 minus A61. And there are 31 such groups. And for all of them, the value we have just proved by AMGM, each of them is 1. Right? And we have also shown that A0 is also 1.
Yes, sir.
So the answer is 32. Very slightly tricky question, but once you understand it, it becomes clear. What we did is we were doing AMGM 32 times. Okay. And if you do AMGM 32 times appropriately, you will realize that all the AMGM inequalities have to be equal, right?
Yes, sir.
Otherwise, it won't work because left hand side should have been bigger, but it was coming out to be same as right hand side. So in that case, the variables on which you are applying AMGM are equal. And from there, we get the result that A2K minus A2K minus 1 is 1. And here K goes from 1 to 31. Once you get this, it is very easy to prove that the final answer will be 32. I hope everyone has understood now.
Yeah.
Okay. Okay, we'll continue in the next class with more problems. That's all for now. See you tomorrow then.
Okay, sir.
Bye, sir.
Bye.
Bye, sir.